Ayan. Okay, class. So, good day. So, now we are on our last chapter of our syllabus, which is acoustics. So, to be specific, engineering acoustics. So, in this chapter, we are going to study sound as well as where we come into the picture as engineers, especially when we talk about acoustic design. So, pag-aralan natin dito, the nature of sound, so how it propagates through a medium, so pati na rin yung mga different parameters niya. So for the latter part naman, medyo technical na tayo and we will learn how to achieve good room acoustics. So let's say for example, you will be asked to design an auditorium. So ano ba yung mga parameters na kailangan mong i-consider and ano yung range ng parameters na yun na wherein you can say that you have good room acoustics. So halimbawa nito, um, kailangan ba may echo siya? Kailangan ba wala siyang echo? Kailangan ba yung material na gagamitin mo ay nag-absorb ng sound? Kailangan ba ay nag-reflect sa ng sound? So, yun yung mga bagay na papag-aaralan natin at the latter part of this chapter. So, for the first part, basic lang muna tayo. We are going to study about sound. So, if we read the description, it says that sound is a physical phenomenon of vibrations that set the molecules into motion through longitudinal waves of compression and rarefaction as it propagates through molecular structures such as solid, liquid, or gas. So by this definition alone, medyo marami na siyang sinabi and we can derive a lot of things about what sound is. So number one, it is a physical phenomenon daw. So when we say physical phenomenon, we need matter for it to exist. So kaya kailangan natin, sabihin, if you want sound to propagate, kailangan mo ng molecular structures such as solid, liquid, or gas. Also, the description also says that yung sound daw natin, nagpo-propagate siya as longitudinal waves of compression and rarefaction. So, as opposed to yung mga usual na napag-aaralan natin, di ba, ang electromagnetic wave, ang kanyang movement or ang alam natin na movement niya is transverse waves. So, this time around, kapag sound yung pinag-uusapan natin, longitudinal yung kanyang way ng pag-propagate. And yung motion na yun, at which this sound propagates through a molecular structure, ang tawag natin doon ay sound wave. So, the transfer of energy from one displaced molecule to another that propagates in a straight path from the source of sound to a listener is known as longitudinal wave. So molecules move back and forth and return to its original position because of its elastic property. So when we say elastic property or kumbaga elasticity, so elasticity class, it is the phenomenon in which a molecule in motion will return to its original position after it transfers its momentum from another molecule. So kumbaga, we say elastic ang property niya because bumabalik siya sa original position niya. For example, applyan mo siya ng pressure, pero after niyang mag-displace, babalik siya sa original position niya once mapasa niya na yung momentum niya to another molecule. So that is the elastic property. And that is how sound wave is propagated in a molecular structure. So, kumbaga, nagbabanggaan yung mga molecules natin. Pag nagbanggaan yung mga molecules na yun, bumabalik din sila sa kanilang original position. However, the momentum is transferred from one molecule to another hanggang makarating tayo doon sa receiver natin. So, as the sound source daw, such as a vibrating object, moves back and forth, it causes compression and rarefaction. So, ito yung nabanggit natin kanina. So, tingnan natin tong mga image na to sa gilid. So, tingnan muna natin tong part na to. So, ang sabi dito, this is a scenario wherein the molecule is at rest. So, kumbaga, we have no pressure. So, kung wala tayong pressure na nagtutulak dun sa molecules natin, wala rin tayong velocity. Now, itong string na to, so this is our vibrating object. So, imagine niyo na lang that is a string of a guitar. So, how does the string of a guitar make sound nga ba? So, nangyayari dyan class, for example, magva-vibrate na tong object na to, tatamaan niya tong molecules na to. Or it will cause this molecule to displace. Itong molecule na to. And kapag yung molecule na to nag-displace, so, syempre, mag-display siya to the direction kung saan siya tinamaan. So, mangyayari class, mag-displace to papunta sa side na to. And kapag nangyari yon, this molecule will hit itong molecule na to. So, ang tawag natin doon sa phenomenon na yun na nagtama yung dalawang molecule is compression. So, ito na yung pangalawang part. So, sa compression class, ang nangyayari natin, the pressure is maximum and the velocity is minimum. Kasi di ba, pag collide nitong molecule na to, nung unang molecule dun sa pangalawa, magsa-stop siya kasi mapapasa niya lahat yung momentum. So, ibig sabihin, at a certain point, titigil yung movement niya. So, ito na yun. Nagtama na yung dalawa. That is what we call as compression. Now, after magtama yung dalawa, syempre, the tendency is these two molecules will react to each other. So, paano yung reaction nila? Ang mangyayari class, the other molecule, the second molecule, will now also move papunta doon sa kanan. Kapag nag-move siya papunta sa kanan, mag-move naman papunta sa kaliwa yung isang molecule. So, ganito yung mangyayari. Ang tawag naman natin dito ay rarefaction. So, at this, class, at this point, minimum naman yung pressure natin. Kasi di ba pahiwalay sila. So, itong dalawang molecule na to, na nauna, the first two molecules, the pressure between the two of them is minimum. However, the velocity is maximum. Kasi di ba pag tama nila, bigla silang mag-split from each other. So, that is rarefaction. Now, siguro as you have guessed, itong part na to, this is another collision. And yung collision na to, that is a compression. So, yung compression na yon, magkakos siya uli ng rarefaction and magdi-displace na naman yung molecule na to and then tatama na naman siya sa another molecule sa kanyang right. So, nakita? So, ganun nag-move yung molecules natin. Ayan. So, ito yung example. So, kung nakikita nyo, this is an example of a longitudinal wave. The other one is a transverse wave. So, ano lang ba yung difference ng dalawa? Kapag sinabi natin na transverse waves, yung direction ng ating wave, parallel doon yung movement ng mga particles natin. So, itong maliliit na to na mga bilog-bilog, those are the molecules. So, kapag transverse ang waves natin, the movement of the particle is perpendicular to your direction. So, in this case, kung ang direction ng wave mo ay papunta dito, kung makikita natin, yung movement ng molecules natin is pataas pababa. So, makikita natin that the movement is perpendicular to the direction. Kapag ka naman longitudinal wave, the displacement or the movement of our particles is in parallel doon sa direction ng wave natin. So, if this is the direction of the wave, makikita natin dito that the molecules also move back and forth. So, ganun yung movement natin. However, huwag kayong malito by the optical illusion. Kasi kung titingnan natin ng mabuti, or kung titingnan natin siya at first glance sa longitudinal wave, akala natin yung molecule nagta-travel from one point to another. But no. Again, di ba, ano nga sabi natin kanina? Elastic yung property ng molecule natin. So, ibig sabihin, bumabalik siya sa original position niya. So, for example, itong molecule na to, na in-highlight ko, it actually just moves back and forth because of this vibrating object. Itong kulay, red na to, that is your vibrating object. Yan. So, itong molecule na to, class, nag-move lang siya back and forth, transferring the momentum, transferring the energy na pinasa sa kanya ng vibrating object to another molecule. And then, yung next na molecule na katabi niya, siya naman yung tatama dun sa susunod na molecule na katabi niya hanggang maulit na maulit yung cycle hanggang makarating tayo dun sa dulo. So, ganun class yung longitudinal waves natin. So, again, even in transverse waves, hindi nangyayari na ang nag-move ay yung molecule. Ang nag-move class, remember, ay yung energy lang. So, yung momentum lang yung pinapasa natin. But the molecule, nandun lang siya. So, next, we have frequency and pitch. And pitch pala, ayan. So, from this point, ang pag-aaralan naman natin is yung mga parameters ng sound. So, number 1, we have the frequency and the pitch. So, correlated tong dalawang to kasi. So, the number of cycle that a vibration completes in 1 second is expressed as its frequency. So, kung gaano daw kadalas sa isang segundo nagva-vibrate yung isang object, kung yan ay string ng gitara, in 1 second, ilang beses nag-vibrate back and forth yung string na yun. Kung molecule yung pag-uusapan natin, like, di ba nag-display siya, how many times na nag-displace yung molecule na yun and bumalik sa original position niya, na kompleto niya isang cycle in just 1 second. So that is the frequency. So any vibrating object creates frequency, but human ear is limited only to hearing the ranges 20 Hz to 20 kHz. So ang sabi, lahat daw, any vibrating object, yan daw ay may frequency. So kahit na ako mismo halimbawa, mag-vibrate ako dito, I have a frequency. However, yung kaya lang mapakinggan ng human ear daw is just 20 Hz to 20 kHz. So meaning, kung hindi mo kayang mag-vibrate ng at least 20 Hz sa kada isang segundo, halimbawa mangingisay ka. So pagka nangisay ka, you need to vibrate at least 20 times sa isang segundo for you to produce sound that we can hear. So ganun class yung ibig sabihin natin dito. And kapag sobra-sobra naman sa bilis, let's say for example, lumagpas ka na ng 20,000 Hz or 20 kHz, hindi na rin siya kayang marinig or ma-perceive ng human ear natin. So as humans, we perceive frequency as pitch. So pitch, it is the relative tonal highness or lowness of sound. So ito yung pitch natin na pinag-uusapan dito is depende sa frequency, yung sensation natin or yung hearing natin is different yung nape-perceive natin. Depende sa bilis ng vibration niya. So ito, tingnan natin to. Ayan. So itong video na to, it is a video of kumbaga single tone from the 20 Hz to 20 kHz. So, kung start natin yung video, makikita nyo, at this point, pataas ng pataas yung signal frequency natin. However, hindi pa natin masyadong naririnig or wala pa tayong naririnig. Kasi again, at that point, hindi pa, kumbaga lower part, hindi natin masyadong naririnig tong part na to. So also, ayan, before I continue, ang human hearing ay nag-deteriorate as we age. So, ibig sabihin, hindi rin tayo lahat pare-parehas ng hearing capacity. Pwede na ako, naririnig ko yung nasa 20 Hz, pero yung iba hindi siya naririnig. Pero yun nga, usually depende yun sa age. But kahit na, regardless of age, pwedeng magkaiba-iba pa rin tayo ng hearing capability. So, continue tayo with the video. Ayan, habang tumataas yung frequency, medyo naririnig na natin siya. So, medyo iingay ito mamaya. So, kung naka-earphones kayo, medyo tanggalin niyo muna yung earphones. Yan, we are at 130. So, nakita, habang tumataas yung frequency natin, tumataas din yung pitch or yung perceive natin ng pitch or pataas din yung pataas yung tunog or yung tone na naririnig natin. Ayan. So, at around 261 or 262 Hz, that is the middle C in the piano. So, kapag pinlay niyo yung middle C, dapat katunog siya nung narinig natin kanina at 262. So, pag kinunti nyo pa natin siya, ayan. So, habang tumataas, paingay ng paingay. Ayan, pataas ng pataas din yung pitch niya. So, skip na natin to higher frequencies. And then, even higher frequencies, pataas ng pataas, patinis ng patinis yung boses. Iyon yung pine-perceive natin as pitch. Ayan, okay. Masakit na sa tenga. Stop na ito. Ayan. So, going back. Ayan. So, yun nga yung sinasabi natin about frequency and pitch. So, ito yung sound frequency spectrum natin. So, ano ba yung sound frequency spectrum pala muna? So, it is the range of the audible frequencies. Meaning, audible, ito yung kaya natin na marinig. So, these are divided into several sections known as octave. Yan. So, siguro yung mga musicians dito, familiar kayo with octave. Or yung mga singers, familiar tayo with octave. Kayo with octave, hindi ako. So, ano nga ba yung octave? So, octave class, it is a range of frequency from its fundamental frequency, meaning yung kanyang basic na frequency, to its double. So, example, isang octave class is itong from 20 Hz to 40 Hz. From the fundamental frequency na 20 Hz, papunta sa doble niya, which is 40 Hz. So, ang tawag natin doon is 1 octave. So, itong sound frequency spectrum natin class, so it is divided into several octaves. Tapos, kinategorize natin yung group ng octaves na yon. So, first na first na range or first na band, we have the low bass. So, yung low bass natin class, it is composed of the first and second octave. So, yung first octave natin, 20 to 40 Hz, 1 octave. And the second octave is 40 to 80 Hz. So, nakita yung difference. Hindi, yung octaves natin, hindi siya constant lang yung difference niya from each other. Excuse me yun. So, hindi siya constant from 20 Hz lang, tapos 40 Hz, 20 Hz yung pagitan nila. So, hindi ganun. So, when we talk about octave, it's from your fundamental frequency to twice of that fundamental frequency. So, kaya ang second octave natin is not 40 to 60 Hz. It is 40 to 80 Hz. So, ang tawag natin doon is low bass. So, next naman is the upper bass. So, yung upper bass naman natin, it is the third octave and the fourth octave. So, 80 to 160 Hz and 160 to 320 Hz. Next is mid-range. So, sa mid-range naman, that is from the 5th octave to the 7th octave. So, 320 to 640, 640 to 1280, 1280 to 2560. Next, upper mid-range, we have the 8th octave. We have the 8th octave. So, nakahiwalay siya kasi class, the 8th octave, this is where our hearing is most sensitive. So, meaning, at these frequencies, ito yung pinaka naririnig natin. Ito yung pinaka nape-perceive natin. Next is the treble. So, yung treble naman natin, that is the 9th and the 10th octave naman. So, 5,120 to 10,240. And then, ang 10th octave natin is 10,240 to 20,000 Hz. So, kasi above 20,000 Hz, hindi naman natin na siya naririnig. So, yun. So, again, yung band natin for the sound frequency spectrum, we have low bass, upper bass, mid-range, upper mid-range, and yung treble. Oops, yan. Next naman, we have amplitude and loudness. So, kung kanina, yung frequency na perceive natin as pitch, kung gaano katinis, gaano kataas, or gaano kababa yung boses. Dito naman, amplitude naman, at saka loudness yung pag-usapan natin. So, this time around, yung amplitude nung sound wave natin, na perceive natin siya as loudness. So, meaning, the higher the amplitude, the higher the sound na naririnig natin. So, yun. Human perceive sound amplitude as sound loudness or softness. So, kapag sinabi natin na amplitude, paano ba natin siya na visualize doon sa ating pangalan nito? Doon sa ating longitudinal wave. So, sa transverse wave kasi, medyo mas madali i-identify kung ano yung mas madaling i-identify paano yung amplitude. Kasi the amplitude is basically the height nung displacement natin. So, kumbaga, ito, yung movement niya pataas at pababa, that signifies the amplitude of a transverse wave. Now, paano kapag longitudinal wave? Similar din naman. It is the displacement of the molecule. So, if this molecule displaces more kesa sa ibang molecule, then ibig sabihin, mas mataas yung amplitude niya. So, iyon yung amplitude natin when we are referring to longitudinal waves. So, imagine niyo na lang, ang structure kasi ng tenga natin, di ba meron tayong eardrum? So, yung eardrum na yon para siyang manipis lang na skin. Yun yung anatomy ng tenga natin. So, meron siyang parang manipis na skin na kapag tinamaan siya ng sound waves, nagbabibrate siya. At kapag nag-vibrate siya, ni-interpret yun ng brain natin as the sensation of sound. So, the more amplitude or the stronger the movement of the molecules, air molecules na tatama dun sa tenga natin, syempre mas malakas yung magiging movement din nung eardrums natin. Na kapag yung eardrums na yon nag-move, nag-equivalent kayo dun sa sound. Kaya 'di ba kapag sobrang lakas ng sound, ano yung nangyayari? 'Di ba masakit sa tenga? Bakit masakit sa tenga? Kasi tumatama siya sa eardrums natin. Na pag tumama siya doon sa eardrums natin, masakit na kasi yung pressure na binibigay ng sound, yun na, masakit na siya sa tenga. So, yung sound amplitude natin, this is measured in decibel. So, yung acoustic sound pressure is measured in terms of sound pressure level or SPL. O, di ba kapag kasi decibel, may reference tayo dyan lagi. So, ano yung reference natin dito or ano yung ginagamit natin to determine the level of sound that is SPL or sound pressure level. So, yung reference natin dito na SPL at 0 dB SPL, meaning that is the faintest sound na kaya nating marinig. At 0 dB, iyon yung minimum na sound pressure na kailangan, na pwede pa tayong makarinig. And then, nag-range siya, of course, into pataas pa siya dun sa spectrum natin kasi pinakamababa nga, di ba, yung 0 dB. Papunta sa around 120 dB. Sorry. Kapag 120 dB na yung level ng sound natin, that is already the threshold of pain. So yung kanina, 0 dB, that is the threshold of hearing. So yung faintest sound na pwede nating marinig, yun. And the threshold of pain naman is 120 dB. Meaning at 120 dB, sobrang sakit niya na sa tenga. Or masakit na siya sa tenga natin. So, yung amplitude natin, tsaka frequency, they are correlated to each other. Meaning, yung loudness is actually naapektuhan din siya ng frequency. So, di ba, pansinin nyo, kung kayo ay gagawa ng isang sound, alin yung kaya nyo na mas gawin na mas malakas? Yung mababa or yung mataas. Or halimbawa na lang, balik kayo kapag engineering week halimbawa. Diba? O mag-cheer tayo, for example. So, kapag nag-cheer halimbawa ang IE, so marami sa IE is, karamihan sa IE is mga babae, diba? So, kapag sila yung nag-cheer, malakas yung boses nila. Pero, i-compare nyo halimbawa kapag mechanical engineering yung nag-cheer. Diba parang dumadagundong talaga yung gym or yung Valencia Hall. Kasi ang bababa ng boses nila, so parang talagang sobrang lakas nung dating ng mga cheer nila. So, ganun ba kumbaga? So, depende sa frequency ng isang sound, iba-iba rin yung na-perceive natin na loudness. So, ito yung graph na yon. So, kapag sobrang baba, itong mga part na to, ito yung hindi kayang i-produce ng voice box natin or tayo as humans, hindi natin kayang i-produce yung ganito ka masyado na sound. So, and then, kung mapapansin nyo, habang tumataas yung frequency at this point, malakas yung sound natin. And then, bababa siya ulit habang tumataas. And then, tataas na naman siya at this point. Tapos, bababa siya, then tataas, then bababa. So, depende kung nasan ka dyan sa curve na yan, yung mape-perceive na loudness is nag-iiba-iba siya. So, kung ito yung 0 dB natin, So, nag-iiba-iba yung mape-perceive natin na sound or yung lakas na mape-perceive natin depende sa frequency. So, what I'm saying is, if halimbawa, ang amplitude niya ng isang sound wave ay constant. Tapos, pero ang frequency niya around 500. Kahit ang displacement ng molecule niya ay pareha sa iba, we will hear it at this point. Ganito kalaki yung level na marinig natin siya. Pero for example, change natin yung frequency into something higher. Andito sa point na to. So, kahit same yung amplitude mo, the level of loudness na maririnig mo ay different because of the change of frequency. So, yun. So, they are interdependent to each other. Yeah. Next na parameter is sound velocity. So, sound velocity class, this is the speed of sound wave in a given medium. So, in-specify natin in a given medium. Bakit? Kasi depende sa medium mo, doon din depende kung gaano kabilis yung sound mo. Kasi di ba, ano ba yung pinag-usapan natin kanina? The movement of molecules or nagta-travel yung sound because of the displacement of the molecules. Not movement, the displacement of the molecules. So, syempre, kapag mas maraming molecules yan, ano yung tendency? If there are more molecules to your medium, then mas mabilis na matatransfer yung sound wave as compared to a medium na konti lang yung molecules natin. So, ito yung mga general na information. So, in air, sound velocity increases as air warms and decreases as it cools. So, kapag ba mainit yung hangin or mainit ang matter, di ba ang nangyayari is nagkakaroon ng mas na-agitate yung mga molecules natin. So, kapag mas agitated yung molecules, galaw sila ng galaw, they are also easier or it is also easier for them to transfer the energy from one point to another. Kasi nga agitated na sila, galaw sila ng galaw, and then tutulak mo pa, so lalo na mas mabilis nila na matatransfer yung sound wave natin. As compared kapag malamig yung molecules natin, di ba, humihinto or hindi naman humihinto, pabagal ng pabagal. Until such point na ma-reach natin, di ba, yung absolute zero, which is 0 Kelvin, yun yung point kung saan wala nang movement or hindi na tuloy, hindi na gumagalaw yung molecules natin. So, kaya in general, sound velocity increases as air warms and decreases as it cools naman. So next, sound travels daw 4 times faster in water as compared to air and 15 times faster in iron or steel. So ano ba yung difference kasi nung nila? Again, the molecular structure. Ang molecular structure ng air, iyan ay watak-watak yung mga molecules niya. 'Di ba? Kapag ka naman water, so ganun din, hindi buo. Wala tayong concrete na structure kapag air yung pinag-uusapan. Fluid pa din siya kapag water yung pinag-uusapan, I mean. Pero 'di ba, ang water mas tabi-tabi yung mga molecules niya. So kung mas tabi-tabi yung mga molecules niya, mas madali na makapagta-transfer siya ng sound compared sa air. So di ko alam mo na experience nyo, pero halimbawa nag-swimming kayo pagkatapos habang nagsi-swimming kayo, di ba mayroong yung mga bakal na nakapitan sa mga swimming pool? Di ba minsan kapag tinamaan yon, tas sumisisid kayo sa ilalim, di ba naririnig natin siya ng malakas? So yun, it's because in water, mas compress yung mga molecules natin compared sa air, so mas malakas natin naririnig din yung sound natin. Mas mabilis din siya nakarating sa atin. And syempre, lalo naman kung totally magkakadikit na talaga yung mga molecules natin, katulad nung sa solid. So talagang, kumbaga parang direkta na yung sound is mabilis na makakarating. Kasi from one point of your solid papunta dun sa kabila, mas mabilis niyang maipapasa yung sound wave. So as a general rule, the denser the material, the faster that it can conduct sound. So, we have some formulas here. So, the velocity of sound daw in dry air, so that is 344.85 meters per second. That is at 20 degrees Celsius. So, room temperature. So, this is the speed of sound daw. However, katulad nung sa statement natin kanina, di ba ang sabi natin, nag-iiba-iba yung velocity ng sound in air at different temperatures. So, ito yung formula natin. That is, the velocity of sound in air is equal to 331.45 plus 0.67 times the temperature in Celsius meters per second. So, ibig sabihin, class, per 1 degree Celsius na increase in temperature, yung velocity mo, class, mag-increase siya ng 0.67 meters per second. Now, however, class, in other books or other sources, hindi ganito. Pwedeng hindi ito yung makita nyo. Kasi nag-iiba-iba or depende sa source nyo, nag-iiba-iba to. Now, baka siya nag-iiba-iba? Kasi class, hindi naman constant na 0.67 lang talaga yung nagiging increase mo per 1 degree Celsius. This is just an assumption or this is just an approximation. In reality, class, hindi ganito ka-linear yung pag-increase ng velocity natin per degree Celsius. So, nangyayari dyan, from 1 degree to another, hindi laging 0.67. However, yun nga, para lang mapadali, meron tayong approximation na ganito. So, baka lang magulat kasi kayo kapag nag-review kayo, iba yung lalabas. So, okay lang yun. Wala namang problema. But the point is, ito nga, habang nag-increase yung temperature, bumibilis din yung velocity ng sound natin. Ayan. So, try natin mag-solve. Example daw. A man standing at Echo Mountain times his shout, returning after 4.3 seconds. So, if the temperature that day is 32 degrees Celsius, how far is the rock face? So, ayan. So, a man standing at Echo Mountain times his shout, returning after 4.3 seconds. If the temperature that day is 32 degrees Celsius, how far is the rock face? So, that is our question. So, tingnan muna natin ano yung meron sa atin na given. One is, may given tayo na time, 4.3 seconds. Given din tayo ng temperature, 32 degrees Celsius. Wala nang ibang given, pero ang hinahanap sa atin ay how far daw is the rock face. Meaning, distance yung pinapahanap sa atin. So, for questions like this, it's better kapag illustrate natin siya para mas madali natin siyang maintindihan. So, ito yung given natin. Time is 4.3 seconds. Temperature is 32 degrees Celsius. Distance yung hinahanap. Ayan. So, imagine, ito yung ito yung man standing in Echo Mountain. And then, this is the rock face. So, sumigaw daw siya. So, sumigaw daw siya. And bumalik yung sound sa kanya after 4.3 seconds. Now, ang tinatanong sa atin is gaano kalayo yung point na to this point. So, we are being asked for the distance. So, yun yung hinahanap sa atin. So, tingnan natin ngayon paano natin siya isa-solve. So, ang meron lang tayo is the formula to get the velocity of sound given kung ano yung temperature. And that is, wait lang, palit ako ng highlighter color. So, ito. So, we only have the formula na velocity of sound is equal to 331.45 plus 0.67 times the temperature meters per second. However, alam natin that velocity, based from our knowledge in physics, di ba? Velocity is just distance over time. So, kasi given sa atin dito yung time, so might as well use it, di ba? So, given yung time, distance na lang yung wala tayo. Given yung temperature, so ibig sabihin, distance na lang yung unknown na parameter natin. So, we substitute d over t dun sa ating velocity of sound. We will get d over t is equal to 331.45 plus 0.67 times the temperature in degrees Celsius, meters per second. So, this is our working formula na. We substitute the values. So, we have for the temperature, we have 32 degrees Celsius. However, for the sound, for the time, ang sinubstitute natin is 4.3 seconds over 2. Now, bakit kaya ganun yung ginawa natin? Kasi class, if we analyze the question, sumigaw daw itong man na to and bumalik sa kanya yung sound after 4.3 seconds. So if that is the case class, yung 4.3 seconds ba is the time at which naabot nung sound wave yung mountain, yung rock face, or the time it took na pumunta na dito, kumbaga the time it took na yung sound from this point, pumunta dito, and then bumalik. So, yun, dun tayo sa pangalawa. Kasi alam natin that the 4.3 seconds na sinasabi dito is the time na nakapunta na doon sa rock face yung sound and then pabalik doon sa man. So, that is why dinivide natin siya sa 2. Kasi kapag hindi natin siya dinivide sa 2, di ang makukuha natin is yung total distance na tinravel ng sound. So, hindi naman yun yung hinahanap natin. Ang hinahanap natin is just the distance of the rock face papunta doon sa sumigaw na tao. So, ayun. So, ito na nga yung class, yung formula natin. So, at this point, pwede nyong i-pause muna yung video and then try to calculate the right answer. Yan. So, yung answer natin is 758.71 meters. So, this is our final answer. That is the distance of the rock face papunta doon sa sumigaw na tao doon sa top ng mountain. Ayan. So, if we have discrepancies with the decimal points, so okay lang naman yun. Ang ginamit ko kasi dito ay online calculator lang. So, pwedeng magkaroon tayo ng discrepancies. Okay, next. Another question. So, a meteorologist studying a storm on the horizon times a thunderclap after a lightning strike to arrive at about 5 seconds on the average. If the storm is about 1.75 kilometers away, what was the temperature that day? So, yan. So, kung gusto nyo, basahin nyo na lang ulit yung tanong. Hindi ko na ulitin yung pagbabasa. So, ang sabi dito, after daw ng lightning strike, after 5 seconds, dumating yung thunderclap. Meaning, narinig mo yung, di ba, thunder is the sound, lightning is the actual lightning na nakikita natin. So, after 5 seconds daw, tinitingnan niya from the horizon, tsaka dumating yung sound. Tsaka niya narinig yung thunderclap. So, if the storm daw is 1.75 kilometers away, what was the temperature that day? So, how do we solve this? So, ito, medyo madali. Hindi na natin kailangan ng visualization. Given sa atin, time is equal to 5 seconds. Ang distance natin is 1.75 kilometers. So, apply lang din natin yung ginawa natin kanina. Kasi hindi rin given yung actual sound velocity natin. So, we're just going to use the same method na ginawa natin kanina, wherein, sinubstitute natin yung velocity as distance over time. So, ito na ulit yung working equation natin. But this time around, ang hinahanap is yung t. Ito. So, we have distance over time. Ang distance natin is given in kilometers. So, in meters per second to. So, convert natin siya into meters. So, 1,750 meters over 5 seconds is equal to 331.45 plus 0.67 times the temperature. So, yan. Pwede nyo ulit siya i-calcu. I-pause yung video into calcu. Our answer is 27.69 degrees Celsius. So, this is the temperature that day. Ayan, okay.